Okay, today we're talking about section 3.3, the slope of a line. And one of the reasons why we're talking about this is because slope is something that defines a line. Now we have many different types of lines. We can have lines that are horizontal. We have lines that are vertical. And we can have lines anywhere in between that. We could have a line that slants this way, or slants even more, or slants even more, until it's vertical. Okay. It could also slant this way until it is horizontal. Okay. And so what defines that is the slope of the line. Now, yesterday we looked at things called parabolas, and parabolas are curves. Okay. Now, curves do not change consistently, so we never talk about the slope of a curve because it doesn't exist. Slope is a constant measure of a line, and it's one characteristic of that line. Okay, so it describes the slant of that line. It's called slope. Okay. It usually gets denoted by the variable m, and an easy way to remember this is that it's how the line rises. So, for in this case, we have a rise, okay, over how far it runs. Okay. So a run would be an x value, and the rise is the y value. Here's the y value, here's the run. Okay. So rise over run is often how it's talked about. It's the change in the y variables, hence y2 minus y1, and the change in the x variables, x2 minus x1, where these come from ordered pairs, x1, y1, and x2, y2. Okay. So you've heard the saying that the shortest distance between 2 points is a straight line. So for any line we can pick 2 points. The slope will be constant in between there. So it doesn't matter which 2 we pick, because of the consistency, we'll be able to calculate the slope. Alright, so in this case, let's call this one x1 and this one y1. It doesn't matter. We'll call this one x2 and this one y2. Okay. Now, slope is the change in the y's, y2 minus y1. That's our rise over our run, which is x2 minus x1. Okay. So y2, in this case, is 0. Then we'll subtract from the formula y1, which in this case is 5. Okay. Then we'll divide that by x2, which in this case is 0. We'll subtract from the formula, and then we subtract x1, and in this case, x1 is negative 2. Okay. Alright, now all we have to do is simplify. 2 minus 5 is negative 3, over subtracting the negative makes it a plus. So this is equal to the slope of this line is negative 3/4. So what we should notice here is that the slope of this line is negative, and that the line falls from left to right. Alright, now here we have a graph that actually rises as we go from left to right, and let's see what its slope is. Okay. Now here we need 2 points because slope is always defined as y2 minus y1 over x2 minus x1. Okay. So we'll need 2 points. So from here, I can see I have the point 0, 2, that is the y-intercept, and here I have the point negative 1, 0. It's an x-intercept for this line. Okay. So now let's call this one x1, y1, and this one x2, y2, and we'll calculate. Okay. So y2 in this case is 0, then I'll take a minus from the formula, and then y1 is 0, over x2, which in this case is 0, then minus from the formula, and then x1, which is a negative 1. So remember, we'll want to put in parentheses. And now we can simplify. 2 minus 0 is 2, and this becomes 0 plus 1, which is 2 over 1, which is just 2. Okay. So in this case, we have a positive slope, and we have a line that rises from left to right. Okay. So those are two different types of lines. This will be known as an increasing line. This is known as a decreasing line. You can imagine if you were standing on top of this line, you would be sliding down, so you'd be decreasing. But here, if you were standing on it, you would need to be walking up. All right, now we had also said that the slope of the line is the rise. Okay. So if I look at how I get from here down to the next layer, if I was going to form the triangle, there is a height of 2. Okay. And then over the run, I have to run this direction. Okay. So if you think about it in terms of direction, I dropped -2 here, and then I ran -1 that way. And so if we put the rise, -2, over the run, -1, when we reduce, the two negatives become positive, and we get 2 over 1, which is just 2. Okay. So it's the same thing. Okay. Alternatively, I can determine the next point on the line. Okay, so instead I don't want to drop -2. How about I rise +2? Okay, and then I want to run another one. Okay. So what point would this be? Well, in the x value, I went 1 more, so this is the point 1, but then in the y value, I went up 4. 2, 4. I went up from the number 2, I rise to 2 to get to the number 4. Let's see if we can see that happen here as well. Now if I want to get from this point to this point, okay, I would have to, if we think about it in terms of, okay, so this is going to come over. Down this way, and I think about it as going, since I'm going down, I went -3 units. Okay. Alright, now I can run this direction, and I'm heading in the positive direction, so I actually went over 4 units. 1, 2, 3, 4. Okay. So you can see then that rise over run is -3 over 4. And it didn't matter. We could do it this way. If we did it this way, then I would think about, well, I'm going up +3 units. Okay. But then if I want to get back here, I'm heading to the left, so that's a negative direction. So in that case, I think about it going as -4. But it doesn't matter. What I have then on this side is over +4. If I'd gone this way, it's over -4. With this one, I dropped to -3, and with this one, I was +3. But it doesn't matter whether I take -3 and divide by +4, or I take +3 and divide by -4. It's still the same value. Okay? So you can count it out those ways too, if you're given the graph. Okay. Now let's do the next one. In this case, we don't have a graph. All we're given is 2 points. That's all right. That's all we need. Let's call this one x1, y1, and this one x2, y2. And remember that slope, m, is the change in the y's, or y2 minus y1, over x2 minus x1. Alright, so here we go. y2 is 0. Then we subtract from the formula y1, which is 2, over x2, which is -2. And then we'll subtract from the formula x1, which is -6. And now we can simplify. 0 minus 2 is just -2. And this becomes -2 plus 6, which is -2 over +4, which will reduce this to a -1/2. So now without even graphing, and connecting these 2 points, we know that this is a decreasing line because the slope is negative. So it will be a falling line. Okay. All right. Alright, so now let's start graphing each of these. So if we know the slope and a point, we can work with this. Alright, so I need a point -1, -3. Okay. So this is the point -1, -3. Okay. Now I have a slope of 2/3. Okay. Well, I can just count this line out because I know this is the rise and this is the run. So let's see here. The rise we'll do in green. Okay, I have to rise 2, so I come up 1, 2. There's a distance there. And then I can count out 3. 1, 2, 3. 2, 3. So here's a distance of 3. This is a distance of 2. Now I can label what point this is. So the y value for this point went up 2 units. So -3 plus 2 is -1. And now what about our x? Well, x was at -1 and we went 3. So 3 minus 1 is 2. Let's do it again. I could rise another 2 and then come over 3 units. 3, and this would be the point. Okay. So now where are we at? Well, from here, the y value rose 2 units, so instead of being at -1, it's at +1. 2 minus 1 is 1. And then for the y value, or the x value, I was at 2, but I added 3, so now this is 5, 1. Okay. And then I can connect these points. Okay, and this will be our line. Okay. And then we can do the next one. This one has a y-intercept of 5, 0, 5. Okay. Alright. So this is our point 0, 5. Right? And now we need to have a slope. Okay. So our slope is equal to -2. I'd really like to write this as a fraction, because then I would know exactly that the numerator is the rise, and that the denominator is the run. Okay. So that's okay, we can do it. We can write the number -2 as -2/1, and then we will know. Okay. So now if I'm looking at a rise of -2, I'm going to drop -2 units, and then I'll run 1. Okay. And we can do it again, drop -2, and run 1. Okay. So these would be our points. Okay. But we really need to label these. We're not going to have, no one's going to count after us, so let's think about this. Now, if I ran 1, that means my x value is changing by 1 every single time. Okay, so if I was at 0, running 1 gets me to 1, running another 1 gets me to 2. Okay. Now for the rise, I'm actually dropping 2. So 5 minus 2 is 3, and 3 minus 2 is 1. Okay. Now, let's look and plot this point. So we need to be at 1, 4, 5. Let's put a few more hash marks in here, just to help us a little bit. So here's the point 1, 5. Now our slope, we know, is -1/2. So which is it? Is our rise going to be the negative, or is our run going to be the negative? Well, in reality, we get to choose. I can either have drop 1 and run a +2, or I could rise 1 and go -2. Okay? Because all of these numbers are equivalent. Alright, so for this one, if I rise 1 and go -2, I'd be back over here, and we're kind of running out of room. So I think I'd like to drop 1 and then run 2 and drop 1 and then run 2, just to give us a little bit more room. It's your choice, though. Okay, so this will be our rise. We'll take -1 to be the rise. So I'm just going down -1, and then I run 2. And then for another one, I drop down 1 and run 2. Okay. Right. Now these are our points, and I can connect these. But now we need to label them, because no one's going to count after us. So let's see what this points should be. Okay. If I'm dropping -1 each time, I would go from 5 to 4, and then from 4 to 3, because I'm dropping 1. Now in this case, I'm running 2. So instead of 1, I'll go to 3, and then 3 plus 2 is 5. Okay? So these are the points on our line. Now again, we have our special cases that are the horizontal and the vertical lines. So if we think about walking, in this case, we're walking upwards, and it's a slope of 2/3. Okay? That would be easier to walk up than this one, which is much steeper, which is a slope of 2. Okay? So now if we think about this in terms of walking and how much energy we're using, if we're walking on a horizontal line, we should be using no energy at all, and the slope here should be 0. Okay? But let's show that that's actually the case. Okay? So remember, for slope, we just need the change in y's over the change in the x's. So let's pick 2 points on this graph. It doesn't matter. This is the point 2, -2. And then we'll pick one over here. Why not -2, -2? And we'll see what happens. So these 2 points lie on the line. And we'll call this one x1, y1, and this one x2, y2. So y2 is -2. Then we'll subtract from the formula y1, which is also -2. Then we divide that by x2, which is +2, minus from the formula, and then x1, which is -2. So let's simplify this. This becomes -2 plus 2, and down below we have 2 plus 2. Okay? The subtractions become additions. Now, -2 plus 2 is just 0, and 2 plus 2 is 4. And once you're at this point, 0 divided by anything that is not 0 equals 0. So we've just shown that the slope is 0 by the same reasoning that we thought about in terms of walking. If you're walking on a straight, perfectly flat object, it should have a slope of 0. Now, if we think about slopes in terms of that, in terms of walking, a vertical line would mean walking up a straight wall. And we cannot walk up a straight wall. So it will turn out that we should have something bizarre happen with our slope here. Okay. So let's see what happens. y2 minus y1 over x2 minus x1. Again, we'll just pick some points. This is the point 3, 2. And here we'll say 3, -2. But it'll work with any points. Call this one x1, y1, and this one x2, y2. So y2 is -2. Now we're going to subtract from the formula y1, which is 2. Then we'll divide that by x2, which is 3. And we'll subtract from the formula x1, which is also 3. Now when we simplify, we get -4 over 0, and indeed this is a problem. We cannot divide by 0. We see then that the slope is undefined, so we could say is undefined. Okay. So this is what happens with vertical lines. Vertical lines have slopes that are undefined. Okay. And so what we will make the conclusion of is that the slope of every horizontal lines are very easy to walk across, so they should have a zero slope, while the vertical line, you can't walk up a straight wall, is undefined. So that's how we deal with lines individually. There are also two types of lines that we care very much about. Like when you start comparing lines, we really like to know if those lines are parallel, that is, that they'll never intersect, or if they're perpendicular and they intersect at a 90-degree angle. Okay, so for example, our x and y axes form a right angle. Okay. So what will happen then, it turns out that if two lines are parallel, if they're not going to intersect, for example, these two lines never intersect, they are parallel, the x-axis in this line is also a parallel, they will never intersect. These are both horizontal lines, they have the same slope. Okay. These are both vertical lines. Vertical lines have slopes that are undefined, so they have the same slope. Okay. So if two lines are parallel, then their slopes are the same. Now, if you want them to be perpendicular, we have to do more than that. They're going to have opposite signs, so they need to be negative, and then they also need to be reciprocals of each other. Okay. So, for example, if one line is 2/3, if the slope of that is 2/3, then the negative, well, we make it negative and flip the reciprocal. Another example here is if the slope is -3 for 1, let's say, so this little subscript will just say the slope of the first line is -3, then we need the negative reciprocal here. Okay. Now remember, we can write this as over 1, so the negative and the negative become positive. Okay. So the negative of the reciprocal, or positive 1/3. The same thing happens here. If the first slope of the line is -1, remember you could write that as 1/-1, then the second one you need to make it negative and then take the reciprocal, the -1, and then the two negatives become positive. To get 1/1, well, that's just 1. Okay, so that's what these two are telling you. Okay, so now we're going to have a lot of practice about determining if two lines are parallel. Okay, so in our directions here, L1 passes through the points A and B. Okay, so these are the 2 points that we'll use to determine the slope for line 1, and line 2 goes through C and D. And then they're asking if we're perpendicular or parallel. Okay. So let's see how we do that. We'll do it by comparing slopes. So from A to B, maybe I'll do this in different colors. Okay, so from A to B, then we have M is equal to y2 minus y1 over x2 minus x1. Okay. So let's call this one x1, y1, and this one x2, y2. Okay. So y2 is 4, minus from the formula y1, which is 1. x2 is 2, minus from the formula, and then x1 is -3. Now we can simplify. 4 minus 1 is 3 over 2 plus 3, which is 3/5. Okay, so this is a positive slope. Now we'll look here. This is x1, y1, x2, y2. Okay. So m is equal to y2 minus y1 over x2 minus x1. So x2 is y2 is -5, minus from the formula y1, which is 0. x2 is 5 minus from the formula x1, which is 2. And now when we simplify, this becomes minus 5 over 3. And from here, we can see then that this is the negative reciprocal of the first slope. And therefore we can say, this is a great little symbol, it means therefore, you don't have to write it down, the whole word therefore. So therefore, since 3/5 and negative 5/3 are negative reciprocals, L1, that's the line that goes through the blue, and L2, the line that goes through the orange, are perpendicular. Lots of times I abbreviate perpendicular just like that. Okay, and so that's going to be our job for all of these. So let's continue to do that. I'll give you some time to work. I'll just get everything set up. If you can work faster than I am, that's good too. I'm just going to get all these set up. Okay, so now let's go through these and make sure I did this properly. Y2 minus y1 is negative 2, 2 plus 2, 3 minus a minus 1, 4 over negative 2. 4 divided by negative 2 is negative 2. And then from here, negative 7 minus 5, and 5 minus 6. So negative 7 plus 5. 5 minus 6 is negative 1. Negative 5 plus 5 is negative 2 over negative 1, which is a positive 2. So what should we conclude about these? Yes, they are negatives, but they are not negative reciprocals. Also, they're not the same. One is positive, one is negative. So this is neither L1 and L2, L2 are neither parallel, okay, and I sometimes denote it like that, nor are they perpendicular. So, I mean, it's a special case to be parallel or perpendicular. We'd expect that many lines are not. Okay. Now from here, y1 minus this one, and negative 3 minus that one. 1 minus 1 is 0. Negative 3 minus 4 is negative 7. So this is the case where we have 0 being divided by something that's not 0. So in fact, the result is 0. And in this case, y2 is negative 2 minus 0, negative 5 minus a minus 5, negative 2 over negative 5 plus 5, so negative 2 under 0 is undefined. Okay. And so this is actually a horizontal line because the slope is 0. This is a vertical line, and therefore L1 and L2 are perpendicular. Okay, so that's that special case of being perpendicular, the 0 and the undefined. Alright, let's see for our last one now. y2 is negative 7 minus a minus 6, 1 minus negative 2, so we have 7 plus 6 over 1 plus 2, so negative 1 over positive 3. Now in this case, negative 3 minus a minus 4, and 2 minus 5. So negative 3 plus 4 over negative 3, or 4 minus 3 is positive 1 divided by negative 3. And I always bring this negative up top just so I don't lose it. So in this case, we have the same slopes. So L1 and L2 are parallel because same slope. Same slope. Okay. So if you're asked if two lines are parallel or perpendicular, you just need to find the slope of each line and then compare it. Okay? You might want to put these definitions about negative reciprocals and same slopes and then this special case here on a flashcard so it'll help you before you get to the exam. Okay. Alright, now this we're actually this is about interpreting slope, and so we'll have some activities later on about interpreting slope, so we won't cover these for right now, which means that 20 and 21 you're welcome to try, and I would like to see what you could do, especially 21. Try this and email me if you have any questions. It could be a good extra credit later on if we have a good talking point about it. So I'd like for you to think through it. I guess the only thing you need to think about then is T and P, okay? So instead of X's and Y's, it's time and prices. Okay? So go ahead and try 21 and see what you can do with that on your own. Other than that, I think you should be able to get to your homework. Can you find the slope given the lines, given points, asking you about parallel and perpendicularness, vertical and horizontal lines, and then can you graph it like we did earlier, counting up and over and relabeling your points. And then this last 3 questions are about determining the slope, just like we did in the example. Okay, so let me know if you have any questions. I'm here. Send me an email.